Let's see. Anybody got any questions?
I do.
Okay.
Let me get to it. It is from 1-6.
Okay.
And it is problem. It is problem 13.
Okay. Which number again? 14?
14.
14.
1-3.
Oh, 13. Okay, I'm sorry. Let's see. 13.
But I am having trouble on 14 and 15, I guess. But 13 is the one that I have out right now, so.
Okay, can you see what my screen's showing, or is it still showing my PowerPoint?
It's still the PowerPoint.
Okay. I don't know why it won't switch for me, but.
It was the same exact way. It's the same exact thing. It's the same exact thing as my last class, so don't worry. You're not the only one having that problem.
I don't know why it's doing that. So here is, now can you see it?
Yes, I can see it now.
Okay, so if the square root f of x is then A and B. Okay. Huh. Well, that's weird.
Yeah.
Well, I don't know why they gave you this part. Okay, well, it looks like I just need to solve this. Find A and B, which A is less than or equal to 2x minus 2, which is less than or equal to B. Oh, okay, hang on. I know what they're doing. I see the craziness.
Okay.
Let me find my Microsoft whiteboard. And okay, I guess I just switched to this. Okay, share. Can you see my Microsoft whiteboard now?
Yes.
Do you still see my math lab or just the whiteboard?
Just the whiteboard.
Okay, that's weird. All right, first thing you're gonna have to do is solve the absolute value of x plus 3 being less than or equal to 9. Now remember, for the less than or equal to, that's going to be an in-betweeny. So the x plus 3 is going to be in between the 9 and a negative 9.
Ah, okay.
Because here's the less than or equal to's. Now to solve this, I would just subtract the 3 in the middle to cancel it out. And that just gives you the x left in the middle. But if you subtract it in the middle, you also have to subtract it on both ends. So 9 minus 3 is 6, and negative 9 minus 3 is negative 12. Now, that gives me a whole bunch of values. Then it says A is less than or equal to 2x minus 2, which is less than or equal to B. Find A and B. And they're only giving me a, hang on a second, let me scooch this down. A is equal to blank. Oh, okay. All right. Sorry, I had to look it up. I was like, what are they doing? Okay. You have to, oh, this is some crazy math right here. I need more room. Oh, shoot, what's this? That's something from before. Never erased it. Okay. Need another color. Go blue. Then they said A has to be less than or equal to a 2x minus 2, which is less than or equal to a B. What you have to do is transform this x so that it becomes 2x minus 2. So what you're going to do, I'm going to go back to this in the purple. Right now, I just have an x. What I want it to be is a 2x minus 2. So the first thing I am going to do is multiply by 2. I want to get a 2x. Right now, I just have x. So I'm going to multiply this by 2. But that means I have to multiply this by 2 and this by 2. Are you with me?
Yes. Oh,
So it's going to be...
oh wait, I do have a question.
Uh-huh.
What if that 2x was a 3x or a 4x?
Then
Would you still times it? Would you still times it by 2?
No,
Or
multiply it by 3 or by 4 or whatever this number is right here.
okay.
Okay. And so that gets me the 2. Now I've got the 2 in front of the x, but now I also need this minus 2. So now I'm going to subtract 2 from all 3 sections. And so now I've got the 2x minus 2 in the middle. And on the left end, I've got negative 24 minus 2 is negative 26. And on the right end, 12 minus 2 is 10. So A, let's see, I haven't used red yet. This right here is my A, and this right here is my B. And I have the 2x minus 2 in the middle because that's what it said originally. 2x minus 2 has to be between A and B. Well, wasn't that a fun little problem? And then I'm going to go ahead and type them into my math lab just to make sure that I got it right. A was negative 26. Hit enter. And hit enter again. Oh, no, what happened? Oh, it's not. That's right. I'm in review mode. Sorry. I went in as a student and it wouldn't let me do any more work since it was. I could have swore I changed that. Those should be the right answers though for me. Did you follow all that?
Yes, I did. Thank you.
You're welcome. All right, I need to get started on our, okay, PowerPoint. Just share the screen again to be the PowerPoint. Okay, and then I'm gonna close that window so that's out of my face. All right, so we've got section 7 to do today. Hopefully I'll get through it all. And there are actually 5 objectives and we're gonna do all 5, unfortunately. We're gonna do some translating. We're gonna solve interest problems, mixture problems, uniform motion problems, and constant rate job problems. So we're just gonna start with the translating verbal descriptions. And there's a lot of different words that mean add, subtract, multiply, and divide. But they've just given you a few examples here. And they specifically talked about the uniform motion problem. Uniform motion, let me grab my pens. Most people remember this as distance is equal to rate times time. But this says the average speed of an object equals the distance traveled divided by the time required. So if little r is the speed and little d is the distance and t is the time, this right here would translate into r equals d divided by t. The average speed of the object, they told me to use little r is the speed. Then it says equals, so here's the equal sign. And then it says the distance traveled, that's the d. Let me find a color for this. Divided by, so they're going to express it as a fraction bar right there. That's the divided by part. And then onto the purple, the time required, and they said use t as the time, and here it is right there. So that's translating that. And then part B just gives you short little cute ones like the number 5 times as large as x. That just means 5 times x. And in algebra, you just put a 5 next to an x. You don't need a dot or anything because it means to multiply. And then the next one says the number 3 less than x. That would be written x minus 3. Do not write 3 minus x. That would be the number x less than 3. This would be the number x less than 3. Subtraction's not commutative. You cannot flip it around. X minus 3 and 3 minus x are 2 totally different things. So they're not commutative. You can't flip it around. The next one they use is the word exceeds. The number that exceeds x by 4. Exceeds just means go above and beyond, so it's an addition thing. Exceeds, you could say, literally say a sum. A sum is what you get when you add. More than can mean add. Total means add. And then this last one, this one's kind of funky. The number that, when added to x, gives 5. The number that, when added to x, gives 5. When I first read this, I'm seeing a number that, I'm like, okay, a number when added to x gives 5. But what they want is something that represents the number. So I would literally have to subtract x on both sides, and that cancels. And now you can see the number is 5 minus x. So 5 minus x represents that. That was a little confusing. You're trying to write something that represents the number. Now I went into my math lab and I grabbed a couple right here. It says translate the sentence. Let F represent the force, M is the mass, and little a is the acceleration. Make sure that you use whatever letters my math lab gives you, and make sure they're either lowercase or uppercase as given. Don't change them, because I think my math lab will count it wrong if I were to type in capital letters here. But we are trying to translate force equals the product of mass and acceleration. So you have to realize, what's a product? Now in business class, a product is something you sell. But in math class, a product is multiplication. So I am simply going to take the mass times the acceleration, m times a. So product means to multiply. And then number 6 wants you to translate this. The total variable cost of manufacturing X bicycles is $110 per bicycle times the number of bicycles manufactured. And it said, let X be the number of bicycles manufactured. I have to use the letter X here. So when they said the total variable cost is right here, that's what this is saying. C of V represents the variable cost. And this is going to be $110 per bicycle times the number of bicycles. So I'm literally just going to take 110 times the number of bicycles was X. That's all you have to type into my math lab is 110X. And you'll get your positive affirmation. Woohoo! And then further on down in my math lab, number 13 is a word problem where you have to do a little translating. It says the length of a rectangle is 2 meters less than twice the width. If the area of the rectangle is 220 square meters, find the dimensions. Okay, I'm going to draw a rectangle here. And it says that the length of the rectangle is, I already know what the length is. I don't know what the width is. The length is 2 meters less than twice the width. But when I read it, it never says the width is blah, blah, blah. So I'm just going to call the width W, W for width. And then the length is 2 meters less than twice the width. 2 meters less than, that means you're going to be subtracting 2 from twice the width. So that's going to be 2 times the width. Whenever it says less than, yes, it means subtraction, but it's saying 2 meters less than something else. So the -2 has to come after the 2W. That's one of the few times you actually have to switch these two things. You take the 2 meters and the twice the width, and you switch positions with the minus sign in between. Now, they go on to tell me what the area is. So you do have to remember how to find the area of a rectangle. Area is equal to length times width. They tell me what the area is. The area of the rectangle is 220. So that's going to go where the capital A is. And then in place of the length, this is my length right here, 2W minus 2. I'm just going to put it all in green. 2W minus 2. And then I'm going to take that times the width, which was the W. And now I have an equation that I can solve because it's got nothing but W's in it. And when I solve it for W, I'll have the width. And then all I have to do is twice that and then subtract 2 from it, and I'll have the length. Now to solve this, it does require me to use the distributive property. So I am going to distribute the W. I'm going to take W times 2W, and that is 2W squared, and then W times a minus 2, and that's a minus 2W. And as soon as I do that, that W squared shows up, and I'm like, okay, we're into quadratic land. So I got to set it equal to 0. Hope it factors. If it doesn't, I got to use a quadratic formula. Fun times. All right, so I'm going to subtract the 220 from both sides. Cancels out here. That leaves me with 0. And then I'll just have 2W squared minus 2W minus 220. Now, before I attempt to factor, I'm going to do a little trick. That rule about solving equations, the one that says, whatever you do to one side, you got to make sure you do to the other, and you can do anything you want. The left side has a 0. The right side has a 2W squared minus 2W minus 220. 2, 2, and 220 are all divisible by 2. So what you do to one side, you got to do to the other. You got to do it to everybody. And the cool thing is on the left, 0 divided by 2 is still 0. So I don't mess that up. But I'm going to make the rest of this a little easier to factor. Because when your trinomial starts with a W squared, all I have to do is unfoil it. This has to be a W and a W. And then I need 2 factors of negative 110 that add up to negative 1. There's really a negative 1 right here. And that's easy, 11 times 10. That'd be negative 11 and a positive 10. When you multiply them, you get negative 110, and when you add them, you get negative 1. So my 2 possible answers are W is equal to 11, or W is equal to a negative 10. But I can't have a negative width. That's impossible. So this answer gets thrown out. 11 is my answer. So the width is 11, and then the length is going to be 2 times 11 minus 2. 2 times 11 is 22, and 22 minus 2 is 20. And there you have it. And if you double check yourself, take 11 times 20. Take the length times the width to see if you get 220, and we do. Questions on that? So you had to translate, you had to remember what the formula for the area of a rectangle is, you had to then distribute, You then had to notice, oh, it's a quadratic, and then remember how to solve a quadratic equation. And then you had to look at your two answers and realize you can't have a negative width, which in most word problems, negative isn't usually an option. Sometimes it is, but most of the time out in the real world, you don't have negative lengths or negative dollar values or negative anything really. So in order for it to make sense. And then it's just plugging and chugging to find the other answer. Now this PowerPoint has a slide right here, which I'm not going to read to you. I'll let you read that on your own. It's just their steps for solving applied problems. So you can read that later. All right, so we're going to move on to interest problems. And interest is usually represented by the letter I, and it is equal to P times R times T, which is what they show on the next slide. If a principal of P dollars is borrowed for a period of T years at a per annum interest rate R, expressed as a decimal, the interest I charged is, they're going to take however much money, interest is going to equal the amount of money that you borrowed times the interest rate, which is usually a percentage, but you put it in decimal form, and then time is usually always in years. Now, for this section, I think almost all of your problems are going to give you 1 year for time. So really all we have to do is principal times rate, because when you multiply times 1, nothing changes. So, oops, that was weird. But let's look at their example. It says Candy has $70,000 and wants to invest and wants an annual return of $2,800. When they say annual return, that's the interest that we're talking about. She invests the money and she wants the money to make money. That's what interest is. It's when you put your money in some type of an account and you earn interest off of the money. Money making money. And it says it requires an overall rate of return of 4%. She can invest in a safe government insured certificate of deposit, but it only pays 2%. To obtain 4%, she agrees to invest some of her money in non-insured corporate bonds, paying 7%. How much should be placed in each investment to achieve her goal? Okay, so they've got this table here for you. The question's asking for $2 amounts, the principal to invest in the corporate bonds, and the principal to invest in the CD. So you know that she has a total of 70 grand. What we don't know is how is she splitting it up? Is she putting 10,000 here and 60,000 there? Is she putting 20,000 here and 50,000 there? I have no idea. So you just say, well, she's putting some of it here, so they're calling it B. She's putting B dollars where the bonds are, which means the rest of it, she'd have to take the 70,000 and subtract out how much she put for bonds. I mean, think about it. You got $70,000. You're walking around with $70,000 and you walk into a bank and you're like, I want to put some of this money in this bank account. Well, you take some of it, and I don't know what B is. Maybe it's 10,000, maybe it's 20,000, maybe it's $23,562. Who the hell knows? You take some of it and you leave it there. When you walk out of the bank and you go down to another institution, what do you have left? You have the 70,000 you started with minus what you just left. So 70,000 minus B would be how much money she's going to put in their certificate. And then that's the principal, right? Here's my dollar amount. Then you've got the rates. 7% is 0.07, 2% is 0.02. That's the percentages converted to decimal form. And then down here, we have our interest. Now you'll notice time is 1 year. So you can pretty much just ignore time, principal times rate times time. So the interest for the bonds is, they took the B times the 0.07, that's 0.07 B. And then for the certificate, they did this, 70,000 minus B equal times the 0.02, it's right here. And in the end, she wants a 4% return. She wants 0.04 of her 70,000, which is the 2,800. Now, what they do is from this table, they make an equation out of all of this stuff here, those three things. They take the 0.07B right here, plus the 0.02 times 70,000 minus B, and that's going to equal the 2,800. Remember, she puts some of the money in a bond. She puts the rest of it in a certificate, a CD. So she's making some money in this account. She's making some money in that account. And in the end, she wants $2,800. So they distributed, they combined like terms, they divided off the 0.05. And when they were done, they got $28,000. So she put $28,000 in that first account. When she left, she had 70,000 minus 28,000, which means she had an additional, or she had an extra 42,000 left over. And that's what she put in the second account. And then step 5, it looks like they're just checking the math to see if it adds up to 2,800, and it does. Now, when I do these, excuse me, I usually don't make a chart because I actually visualize myself walking into 2 different banks. So, boy, I wish I could do that. Okay. Number 8 says, a bank loaned out $18,000, part of it at the rate of 9% and the rest at 17%. If the interest received in 1 year totaled $2,800, how much was loaned at $18,000? So I'm sitting here going, okay, $18,000 got split up into 2 pieces. Some of it went here and the rest of it went over here. And then the final question was, how much was loaned at 9%? So since I am solving for that one and that one only, that is what I'm going to label as my X. I'm going to put the 9%, which would be 0.09, and I'm going to multiply that times X. Remember, X is your dollar amount, 0.09 is your interest rate, time is 1 year, so I don't put the 1 year in there at all. Plus, and then the other one was the rest is at 17%. So I put the 0.17 in front of that. And the interest received in 1 year totaled 2,000. Total means what you get after you add. So I put a plus sign in between them, put an equal sign over here, and put $2,000 right there. And that's my equation. I see some distributing in my future. All right. So I'm going to have 0.09x plus, I'm going to distribute the 0.17. That's going to give me 3060. And then distribute it here, and I get a minus 0.17x. I have some like terms. I've got a 0.09x and a negative 0.17x. When I combine those, that's going to be a negative 0.08x. I still have the plus 3060, and that's going to equal $2,000. I am then going to subtract the 30/60 from both sides. Looks like I'm going to negative land over here. So those cancel. I'm still going to have the negative 0.08x, and that's going to equal negative 1060. And then all I have to do to solve for x, come up here, x is going to equal the negative 1060 divided by the negative 0.08. Two negatives make it a positive. And when I'm done, I'm going to have 13,250. And that is how much money. So that's a dollar amount there. That's how much money will be invested, or that's how much money the bank loaned out at 9%. Questions on that one? Hey, I'm representing today. If you can see my shirt, it says Ivy Tech. I bought this shirt back in 2000 and I don't know, 2008 maybe, 7.
I sent a question in the chat.
Oh, I didn't see that. Because I've got that closed out. So let me, how can I make this bigger? I'd have to unshare my screen. So can you just tell me what your question was?
Yeah, I was gonna ask, does it matter if you put the 9% and the negative 17%? I mean, not negative, but the 17% in the opposite place.
These two right here, switch them?
Yeah.
It doesn't matter. The only reason I put the 0.09 where I did is because this question only asked about 9%. So I put it with the X. If you had switched these, then when you were done getting X, you actually would have had the answer for the 17%, but then you'd have to subtract it from 18,000 to get the answer. Now, if they had asked me for both, and there's some math lab questions where they want both answers. They want 19 and 17%. As a general rule, I normally put the larger percentage with the X, because that way I will avoid some negative numbers. But does it matter? No, it'll work both ways. Doesn't matter where you put it. Okay?
Mm-hmm.
All right. I got a frog in my throat today. I cannot get rid of it. Sorry. All right. That moves us to mixture problems. And I always enjoy it when they give me an example of alcohol, but unfortunately this book didn't. And then there's always one smartass in the class is like, hey, can we bring in some alcohol to do an actual presentation of mixture? But damn. Okay. A manager of a Starbucks store decides to experiment with a new blend of coffee. She will mix some B-grade Colombian coffee that sells for $5 per pound with some A-grade Arabica coffee that sells for $10 per pound to get 100 pounds of the new blend. I don't drink coffee, but God, sorry. Shit. But I have seen some people, you go down the coffee aisle, I don't even know if they still have this at Kroger's or not, but years ago, I would see people, they'd be like, okay, I'm going to get a little bit of this coffee and a little bit of this coffee and a little bit of that coffee. Like they can't afford the really expensive stuff, but they're like, okay, I'm going to get the cheap crap. And then I'm going to get a couple of spoonfuls of the expensive stuff so that the cheap crap isn't so bad. I've seen that. I've also seen kids at the gas station, and I'm up there getting my Coke, and they're like, Coke, Sprite, Dr. Pepper, what do they call those? Kamikazes or something? I don't know. suicides, and they're just mixing all sorts of stuff. And so one day I got a wild ass hair up my ass, and I looked at the kid and I said, exactly what percentage of Mountain Dew are you putting in that drink? And they just kind of looked at me. So guess you had to be there. All right, back to the coffee. The selling price of the new blend is to be $7 per pound. And there is to be no difference in revenue between selling the new blend and selling the other types. How many pounds of the B grade Colombian coffee and how many pounds of the A grade? They're going to mix both, or they want the answer to both. And they've shown a lovely picture here. Look at that, scoops and everything. And they didn't do a chart. This is kind of how I would do it. This is what I literally see, is I see you've got the B grade here and you got the A grade there. They're trying to figure out how many of each are they going to mix together. And they want 100 pounds when they're done. So call one of them, and they used what, C for coffee. How many pounds of coffee of the B grade? And then they said 100 minus C is the A grade. It's just like the money. The 18,000, we put some of it here and the rest of it there. Well, we have a total of 100 pounds of this blend. So some of it is B and the rest of it is A. So and they use C and 100 minus C. And just like the percentage problems with the mixture and money, they said that the Colombian coffee cost $5 for every single pound. So that's 5 times C. And then the A grade was $10 times every single pound. And in the end, you're going to have a $7 blend for every single pound. Now this one, you do have to throw in the $7 on the end. And 7 times 100 is 700. So here's the equation. Here's blend B. That's how much it's going to cost. This is how much it's going to cost for blend A, and the total cost was $700. And then they did the math and they solved for C and they got 60. So you're going to need 60 pounds of the B grade. And then of course, 100 minus 60 is 40 pounds for the A grade. And they double checked it. They said, if I buy 60 pounds at $5 a pound, that's $300. And then 40 pounds at $10 a pound, that's $400, which does add up to 700. So kind of double checks it, make sure you did it right, which is a nice thing to be able to do. So I grabbed 2 mixture problems from my math lab. The first one involves nuts. A nut store normally sells cashews for $4 per pound and peanuts for $1.50 per pound. But at the end of the month, the peanuts had not sold well. So in order to sell 90 pounds of peanuts, the manager decided to mix the 90 pounds of peanuts with some cashews and sell the mixture for $3.50 per pound. How many pounds of cashews should be mixed with the peanuts to ensure no change in revenue? Okay, I should go get my peanuts out of my cabinet, but I don't have any cashews. Okay, so you got some cashews, right? And you're gonna mix them with some peanuts. And that's gonna be your new mixture. Cashews, all right. Cashews sell for $4 per pound. So cashews is going to be $4. And then peanuts sell for $1.50 per pound. So this is going to be $1.50 for my peanuts. And in the end, the mixture will sell for $3.50 per pound. Okay. Now, I got to go back in here and find how many cashews, how many pounds of cashews. They don't tell me that. They do tell me the peanuts. In order to sell 90 pounds of peanuts, so 90 goes right here. I got 2 blanks. I have 2 blanks on this one. I have circled all the numbers that were in this problem. This is still 90 pounds of peanuts right there. $4 for cashews, $1.50 for peanuts, $3.50 for the mixture, and the only thing they give me is 90 pounds of peanuts. So this is an algebra class, people. X has to be in there somewhere. And since they're asking me specifically, the manager should mix blank pounds of cashews, I'm going to put my X right there because that's what I'm looking for. So the question is, what goes over here? Well, isn't that how many pounds you have in your mixture? Which would be 8 pounds of cashews. Let me find another color here. If you mix 8 pounds of cashews with 90 pounds of peanuts, wouldn't that be X plus 90 pounds of a mixture? That's my equation. It's $4 for every pound of cashews. I don't know what my cashews is. That's what I'm looking for. So I just called it X pounds. It's $1.50 for every pound of peanuts. I do know how many peanuts I have, 90 pounds. And then the mixture is $3.50 per pound. Well, my total mixture is going to be however many pounds of cashews I have plus the 90 pounds of peanuts. And all I got to do is solve this mess for X. So I'm going to switch to a black pen. This will be 4X plus, when I take 1.5 times 90, I get 135. And then when I distribute over here, I get, I'm just going to write this as 3.5X plus 315. Now, I've got more than one X in the problem, so I need to subtract that off. So I'm going to subtract 3.5X from both sides. That way it cancels out here. But in the same breath, if you don't mind, I'm also going to get rid of this minus one, or get rid of this 135 by minusing it. That gets rid of that on the left side. So now I have all my X guys on the left and all my non-X guys on the right. So 4X minus 3.5 is 0.5 X's, and 315 minus 135 is actually 180. And to solve for X, I'm just going to take the 180 and divide it by the 0.5. And that comes out to be 360. And we're talking pounds here. That's a lot of cashews. Of course, we're trying to get rid of some of the peanuts. They're kind of just throwing a few peanuts in there with the cashews, and hopefully nobody will notice. I'd notice. Questions on that? What if they'd asked me, instead of asking me how many pounds should they mix of cashews, what if they'd asked me, how many pounds will you have in your total mixture? Then I would probably put my X, let me find a different color here. I would have put my X right here. If that's what they wanted to know, if they wanted to know the total mixture, the total pounds in the mixture, I'd put X there. But then this would have to be whoops, X minus 90. Sorry about that. Because if there was 90 pounds of peanuts, then the cashews would have been the total mixture minus the 90 pounds that were peanuts. So you kind of have to look at what they're asking you to find and where you're going to put your X. So it still would have solved out the same. All right, and then number 15. Now this one involves percentage, and they're using antifreeze. Would have been more fun if this had been an alcohol problem, but it says how much water should be added to 1 gallon of pure antifreeze to obtain a solution that is only 30% antifreeze. So you've got pure antifreeze and you're trying to water it down basically. So it's only 30%. Kind of like, you know, watering down the punch, or maybe not watering it down, maybe, you know, boosting the alcohol in it. I miss college. Okay. This is just like a mixture with the amount of peanuts and cashews where it's, you know, a dollar amount, except this time it's a percentage amount. So let's see. How much water, we're going to take water, should be added, so we're going to add it to 1 gallon of pure antifreeze. So here's my antifreeze. To obtain, come on pen, to obtain, so equal a solution that is 30% antifreeze. So this is pure antifreeze, which means if it's pure, doesn't that mean it's 100%? It's pure antifreeze, nothing else in there. And then we want to get a solution that is 30% antifreeze. So 30% antifreeze. Okay, well, what I need is a percentage on the water. Now, a lot of people are like, well, it's water. It's 100% water. No, 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 no. This problem is a mixture based on antifreeze. Everything is percentages of antifreeze. This one is pure, so that's 100%, pure antifreeze. This one they said is still antifreeze, but they only want it to be 30%. So the big question is, how much antifreeze is in water? 0. Water has 0% antifreeze. I also know how many gallons of the pure stuff, that's 1 gallon. So I've got 0% water. I've got 100% pure antifreeze. And then I've got 30% of this mixture. The question was how much water. So one of those 3 parentheses has to have just an X in it. And that was the question. It was how much water should be added. So my X, how much water, that's my X, goes right there. They told me I had 1 gallon of pure antifreeze. That number 1 goes right there. And then this is a mixture. My mixture is going to be how many gallons of water plus how many gallons of pure antifreeze. So this is going to be X plus 1 right there. Now this equation works out quite nicely because 0 times anything is just 0. So this literally becomes just 0. And if you have 100% times 1, you still just have 1. But over here, I'm going to have to change my 30% to a 0.30 because I then have to distribute that through the parentheses. So I'm going to have 1 is equal to 0.30x plus 0.30. I'm going to have to subtract the 0.30 from both sides. Subtract 0.30, subtract 0.30. Cancels out there. 1 minus 0.30 would be 0.70. And that's still equal to 0.30x. Come with me. So x is going to be the 0.70 divided by 0.30. And when I did that, I got 2.3333 blah, blah, blah. My math lab says simplify your answer. The only way it would take it is a fraction. And 0.3 repeating is actually 1/3. So I'd have to add 2 1/3 gallons of water to my 1 gallon of pure antifreeze to water it down to just 30%. Okay, so that's mixtures. And then the next one is uniform motion problems. Okay, that's the distance equals rate times time. But if distance equals rate times time, you could also say that distance divided by time is the same thing as rate, or distance divided by rate is the same thing as time. I might need any one of these three, because sometimes you may be dealing with the distance, sometimes you may be dealing with the rate, sometimes you may be dealing with the time. So you might have to solve, for rate, which is distance divided by time, or solve for time, which is distance divided by rate. So keep that in mind. Now their example, Tanya, who is a long distance runner, runs at an average speed of 8 miles per hour. 2 hours after Tanya leaves her house, you leave in your Honda and follow the same route. If your average speed is 40 miles per hour, how long will it take before you catch up to Tanya? And how far will each of you be from your home? Now the next slide shows a lovely picture of the house. Tanya running, and then there's the Honda. That looks, doesn't look like a Honda to me, but okay. And up here, he catches up. You catch up to Tanya. Okay. Both Tanya and the car start at the same spot and end at the same spot. So the one thing that I know for sure is they both have the same distance. They're definitely not going the same speed. She's going 8 miles per hour. And they said that the car, you're in your car and you're going 40 miles per hour. So the rates are not the same. And the time is not the same either, because it says, let's see, how long will it be before you catch up to Tanya? And Tanya had already been running for 2 hours. You left 2 hours later. She hasn't stopped running. She's still running, but she's already been running for 2 hours. And we're trying to figure out how long does it take the car to catch up with the girl. So we're looking for time, and that T is definitely for the Honda. Tanya's time would be the same time as the Honda plus the 2 hours that she had already been running. So her distance is 8 hours times T plus 2. And the Honda's distance is 40 miles per hour times t hours. And then of course, we know that the distances are the same. So we're gonna take this and set them equal to each other right there. We took, this is the distance that Tanya goes, and this is the distance that Honda goes, and they go the same distance. So just set them equal to each other. Then they distributed. Then it looks like they subtracted 8t and switched sides, and then they divided by 32, and it was a half an hour. So it'll take the Honda a half an hour to catch up to Tanya. And each will have gone 20 miles. Once you get that half hour, the easiest thing to do is take the 1/2 hour and plug it in here, because 40 times 1/2 is 20. But you could plug it in here also. It's going to be a little more difficult. 1/2 plus 2 is 2.5, and then you're going to multiply that times 8. So I would change that to 2.5 times 8. So I could use my calculator a little easier, or you can use the fraction buttons on your calculator, but that's also going to equal 20 when I'm done. So now that's one example. They actually give another example in here. A motorboat heads upstream a distance of 24 miles on a river whose current is running at 3 miles per hour. The trip up and back takes 6 hours. Assuming that the motorboat maintained a constant speed relative to the water, what was its speed? Now, I've been in canoes before, you know, where you paddle yourself. And when you are going downstream, you don't have to paddle as hard, do you? Because the current takes you with you. But if you turn around and try to paddle going upstream, isn't it a lot harder because the stream is working against you? I can do the same example if I'm on a bike. When I was a kid and it was a windy day, if you are trying to ride your bike into the wind, it is so hard to pedal because the wind is forcing itself against you. But if you turn your bike around and you start riding with the wind, it's like, whee, you know? So however fast the stream is going, you are going to add that rate if you're going downstream, but you'll have to subtract that rate if you're going upstream, because it is going to slow you down. Now this is in a motorboat. So, you know, just like a car, I assume in a motorboat, you can like put it on cruise control and the motorboat will just, you know, maintain its same speed. I don't know if you can do that or not. But anyway, that's the concept behind it. Now they went back to a table again on this one. And they said, okay, we are looking for the rate of the motorboat. So we'll let R be the rate of the motorboat. But if the motorboat is going upstream, its rate is going to be reduced by the current, which was 3 miles per hour. If it's going downstream, it's going to be increased by the current. It's going to speed them up a little bit. So that's R plus 3. The total distance, let me go read this again. A motorboat heads upstream a distance of 24 miles on a river whose current is, okay. The trip up and back takes 6 hours. Up and back. Up and back takes 6 hours. Where's the 6 hours? They didn't put it in there. Well, they said that the time was 24 divided by R minus 3. I'm not seeing the 6 in here at all yet. Okay, we got the rates. The distance would just be, this 24 is just going uphill or upstream or just going downstream, one or the other. Whether you're going upstream or downstream, it's 24 miles. Oh, okay. I don't know. I know the total time. My bad. Brain fart. I know the total time. I don't know the time that it took to go upstream. What was the time there? I don't know. What was the time to go downstream? I don't know. The total was 6 hours. So you're going to use the fact that time is the same thing as distance divided by rate. And that's what they're doing right here. They took the 24 miles, which is its distance, and divided it by the r minus 3, because that would be the rate going upstream. And then they took the 24 miles, which is the same distance going downstream, but the rate going downstream is r plus 3. And here's a lovely picture. Now, the total comes into play when it's the total amount of time, which is the next equation. If you take this was the amount of time going upstream, and this was the amount of time going downstream, and 6 is the total. So they put an addition sign and an equals 2 in there. And then they went to town on the algebra. Look at all that algebra. Doesn't that look like fun? Looks like they got a common denominator. I wouldn't do that. I would get rid of it. And then they FOILed that out. Combine like terms, distributed, combine like terms, FOIL the denominator, and then multiply both sides by the r squared minus 9. And then they distributed and set it equal to 0 all in one step when they went from here to here. I love it when they skip steps, don't you? And then from here to here, they divided by 6, and then they factored, and they got a negative answer, which you can't have a negative, so 9's the only answer. So the motorboat was going 9 miles per hour. Whew. Okay. Let me grab my math lab one. It's another motorboat problem. Okay, same miles per hour. Oh, now this time they told me the speed of the boat. The motorboat maintained a constant speed of 24 miles per hour relative to the water in going 16 miles upstream and then returning. The total time for the trip was 1.5 hours. Use this information to find the speed of the current. This time they want the speed of the current. Okay. In my math lab example, they wanted the speed of the motorboat. Here we want the speed of the current. I'm still dealing with a total time of 1.5 hours. So I need the time going up added to the time going downstream, and that's going to equal the total time. And the total time was 1.5. I have no idea how much time it took to go upstream, but remember, time is the same thing as distance divided by rate. And they told me that it was 16 miles upstream, which means it's 16 miles downstream. So for each one of these, I'm going to have a numerator of 16. Now, the denominator, this is where it's a tad bit different. The boat was going 24 miles per hour. We're looking for the speed of the current. Find the speed of the current. I need to change that to red, sorry. There we go. Because gray is just too depressing of a color. The speed of the current I'll call R. However, the motorboat was going 24 miles per hour. So going upstream, he's traveling 24 miles per hour, but the current is slowing him down. So the current is going to reduce his speed by whatever the current is, in this case, R. But when you're going downstream, it's going to speed you up. So you would add r. And that's my equation. It's ugly, but that's what it is. Now I'm going to work mine just a little bit differently from theirs. I like to clear out my fractions. So I would multiply all three of the sections of my equation by the common denominator, which would be a 24 minus r times a 24 plus r. So that this one cancels out that one. And I would just be left with the 16 times the 24 plus r. Over here, my 24 plus r cancels this 24 plus r, and I'm left with the 16 times the 24 minus r. And then over here, I'm going to have this 1.5 times, and I'm going to go ahead and FOIL this right here. They are conjugates. So 24 times 20, all I have to do is first times first and last times last, because outsides and insides cancel. So this is 576 minus last times last is r squared. And now I'm gonna distribute to get rid of all my parentheses. Okay, so I'm going to distribute the 16 here. That's going to be 384 plus 16r plus, I'll distribute this 16. That's going to be 384 minus 16r. And I'll distribute the 1.5 on this side. And that's going to be 864 minus 1.5 r squared. Now, on the left, my 16r squareds, they're going to cancel out. That guy's going to cancel that guy. And I'm going to combine the 384 and the 384. Sorry, I didn't have this one worked out ahead of time. That's 768 is equal to the 864 minus 1.5 r squared. I have run out of room, so let me add a slide here. Okay, so I've got 784 equaled, can't even remember now, 864 minus 1.5 r squared. 864 minus 1.5 r squared. If I subtract the 864 from both sides, cancels there, I get negative 80 equals negative 1.5 r squared. So r squared is going to be negative 80 divided by negative 1.5. A negative divided by a negative makes it a positive. And I'm going to get 53.3333 equals r squared. I'm going to leave that number in my calculator because to solve for r, I have to square root both sides. So the square root of 53 point blah, 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 blah. Let's see, where's my square root button? Comes out to be, I got 7.3029. If my math lab wants me to round it off, what did my math lab say? Okay, did I make a boo-boo? Because it doesn't tell me to round unless it wants a fraction. Urgh. And I am at 5:15. Okay. But right now I'm going to go with it's either positive or negative, but you cannot have a negative, so you'd throw that out. So I would go with 7.3. I may have made an error in here when I was doing my math. So, because I didn't work this one out ahead of time. That always happens. Teacher's worst nightmare, trying to do something on the fly and it messes you up. I still have to go over the last few slides, which covers the constant rate. So I will, hang on a second, go here. Stop share. I'm going to go back over that problem myself, make sure I didn't mess up, and then I will talk about it on Wednesday, finish up that last part of the PowerPoint on Wednesday. And then I'm going to have a review sheet for you guys. I will post it in the modules, hopefully by tomorrow. And that's something we're going to work together in class. So you might want to print that one out when it's posted and follow along to help review for your, well, our first test isn't for a while yet, but it's just going to be like a review of everything we've covered so far. Okay, sound like a plan for all of you that are out there?
Hey, April.
Yes.
That's good.
I came in at 4:30. I just completely lost track of time. Did
Okay.
I miss anything? I mean, I know I can look it up on your Zoom or your YouTube math page.
Right.
But did I miss anything important or?
You always miss things important in my class.
Yeah, I know.
Yeah, go back and watch it. It starts the translation, and then I think we hit the first kind of word problem. So yeah, there's some
Okay.
word problem stuff in there you might want to.
Does that affect attendance or anything?
No, not at all.
Okay.
Nope,
All
not at
right.
all. Nope.
See you Wednesday. Thank you.
Okay. All right. I'm signing off, people. Enjoy the rest of your day. See you Wednesday.